So before we begin, let me switch to the terminal. So we'll be running this demo of using Authorino as a generic validating webhook service that will be used in this case to validate other AuthConfigs applied to the cluster, and leveraging this new feature of Authorino, this new interface that we introduced, which is the raw HTTP authorization. But before we begin, just run these relatively heavy tasks of creating the cluster, and then I will switch back to the slides, and I can explain exactly what we are doing. This should be in a second. Yep, and I will be watching the workloads for the entire cluster in this other terminal here. Good. Let's just wait for the main Kubernetes workloads to be running, so I can start creating the apps that we need. Cool. So let's deploy Keycloak, DAX, a couple SSL servers. We'll also install Set Manager and install the Authorino operator. And while we wait for all this to be available, to be ready, I will switch to the slides. So people are used to these deploy types of these ways to deploy Authorino, right? So it's either a centralized service, a centralized gateway, a centralized authorization service, or in some cases as a dedicated authorization service. But usually, in almost all the cases, there is Envoy involved, right? So there's Envoy that establishes a gRPC connection with Authorino, both complying with the Envoy external authorization gRPC protocol, right? Technically, it is also possible for applications to connect with Authorino directly without having Envoy involved, as long as those applications could implement the same protocol as Envoy, meaning implement a gRPC client to connect directly with Authorino. This is not a common use case, not a typical use case, but it has always been technically possible for applications to connect directly with Authorino via gRPC, which is something that we represent either here or here. Doesn't really make much sense in the case of the centralized gateway, but for the other types of topologies, it does. What is new that we introduced in this latest sprint is an alternative regarding the protocol, a different way to establish the connection between the client and the Authorino authorization server, right? And this new interface is we've been calling it the Authorino raw HTTP authorization. It's an alternative to the gRPC default one. It's been introduced in this pull request here, 273. Internally, it reuses basically the same implementation that we have for the gRPC interface, which basically translates to you can use the same AuthConfigs in both of them. There's no difference. It's only the interface, the way to establish the connection. It is compatible with this option of Envoy external authorization protocol, which is the HTTP service option. This is an alternative to gRPC service. Honestly, I don't know why one would rely on HTTP service if gRPC is available. But anyway, since we were implementing the HTTP interface, it made sense to make it compatible. And it wasn't like too much work anyway. The HTTP authorization interface listens to the default port 5001, while the gRPC one is 50001. The gRPC exposes a method /check. So to keep consistency, we also implement this new interface under /check. It uses the host HTTP request header to look up for the AuthConfigs. And it always injects the payload, the body of the HTTP request serialized in this JSON path here. So inside of an AuthConfig, you can refer to the body and you can parse the body, for example, either using OPA or using a JSON path. By the way, this is something that we can also do with Envoy. Envoy can also inject the body of the request in the original request. In the inner request, it sends to the external authorization server. It's just that Envoy does not do that by default. You need to enable that in the Envoy configuration, while in the HTTP authorization interface, it does that by default. And it will respond with a simple HTTP status code, like 200, 401, 403, 404, and so on. Of course, since all the features of an AuthConfig are available, we can also use the deny with option of the AuthConfig, which is the one that allows you to customize the denial messages. Another characteristic of this new interface is, and probably the most important one in this for this demo here, is that it auto detects the payload, whether it is formatted as a Kubernetes admission review resource, in which case it will also wrap the response as an admission review resource in Kubernetes. And that basically enables one of the use cases, which is the use case we'll be demonstrating, which is using Authorino as a validating webhook service. So hopefully by now you already realized the kind of use case we had in mind, why we implemented. Just to make it clear, so it's for other types of integration with Authorino, non-based on gRPC, non-envoy, for example, like other proxies, or direct integration of applications based on HTTP. And as a more specific case inside of this more generic one, we have using Authorino as a validating webhook service, meaning using Authorino to validate requests to the Kubernetes API. Including, for example, that is valid for any Kubernetes resource, right? But including when you use the Kubernetes API to try to modify, to create, to update AuthConfigs, Authorino AuthConfig custom resources. And that virtually means using an AuthConfig to validate other AuthConfigs, for example, to enable, disable Authorino features in a particular cluster or for a particular Kubernetes user, right? So this is how the Authorino CR looks like. To deploy this, we can skip this. And this is basically the demo we'll be running now, right? So whenever a user sends a request to create or update an AuthConfig to the Kubernetes API, then given we will have a validating webhook configuration that points to an instance of Authorino running the cluster, for whenever the operation regards changing AuthConfigs, the Kube API server will send a request to the an admission review request to Authorino. Authorino will look up for an AuthConfig, which will be an AuthConfig that will validate other AuthConfigs, and it will respond back to the Kubernetes API server with either OK or not OK. If Kube API server receives 200, it will persist the change in etcd, meaning it will persist the new state of the AuthConfig that is being applied by the user here. Otherwise, it will return as forbidden, right? And this AuthConfig that validates other AuthConfigs will look like more or less like this, as you can see on the right? So the host is the host name of the Authorino service running in the cluster, and the one will be configuring the validating webhook configuration. And as specific rules of things that we want to validate, in this case, we'll be doing this. The identity will come from, will be extracted from the context. That is because the Kubernetes API server already authenticated the user when the request reaches Authorino, right? So you already have information about the user. Authorino does not need to re-authenticate the user. It just needs, you can trust the information in the context and just extract from that. So it can effectively enforce these two authorization policies here. Number one is, this is for our example here, it will ensure using OPA that only Authorino OIDC identity method is used in any AuthConfig, meaning all the other identity methods provided by Authorino, like API keys or Auth2 or Kubernetes tokens or whatever, it will be disabled in this cluster, and only OIDC will be enabled. And as a second policy, Authorino will use the Kubernetes AirBox to verify whether one of the two SSL servers here can be used by that user. By default, all users can use the Keycloak instance running in the cluster in an AuthConfig, but the DEX SSL server will be restricted only to users bound to a particular row in the Kubernetes AirBox. Okay, back to the terminal. So let me just create a namespace to deploy Authorino, create some TLS certificates for Authorino, deploy Authorino. So again, we are activating the HTTP raw HTTP authorization interface on port 5001. Authorino should be running here, or it will in a sec. Yes, starting. This is basically the AuthConfig that validates the other AuthConfigs, right? The one that the admission review requests will be used to validate the admission review requests. Right? And the request will be sent to this host name here. This is just a condition. I will not get into too much details, but since this is also an AuthConfig, right? Every change regarding this particular AuthConfig would also be validated by the same AuthConfig. The latest state of the same AuthConfig persisted. So this is something we are doing only to skip changes related to this one AuthConfig or to any AuthConfig that are in the namespace Authorino, right? But all the other ones, meaning the AuthConfigs created by users in the other namespaces, will be subject to the rules in this AuthConfig. So extracting the identity here and the two authorization policies that I mentioned. One that will forbid all the identity modes, right? And the other one that will use Kubernetes subject access review to verify whether the user can use DEX, right? So let's apply this AuthConfig. I will also create the role that will be used to grant access to the DEX SSL server. And finally, I will create the validating webhook configuration, right? So the rules are, whenever there's an attempt to create or modify an AuthConfig, the Kubernetes API server will send a request, an admission request to the instance of Authorino running behind this service here. Right, so great. Okay, now we should be ready to try this out. So now let's forget that I was the cluster administrator applying all these steps, and let's pretend I'm somebody else, another user. And as this other user, but for simplicity, I'll just stay with the same session here, but let's assume that this is a regular user creating a namespace where the user will will deploy applications, and it will eventually try to enforce an AuthConfig to protect its application, right? So let's skip straight to the step where the user tries to apply an AuthConfig. So let me go into the terminal here. So first, the user will try to apply this AuthConfig here, which, as you can see, is defining to protect this app here, API key-based authentication, right? So if we try to run this, the Kubernetes API server sends a request to Authorino. Authorino uses the AuthConfig validator AuthConfig to verify this other one. It says forbidden, unauthorized, right? And because of that, if we try to get the AuthConfigs here, you see that this particular AuthConfig has not been persisted, right? While if the user changes to OIDC, which happens to be the only identity mode enabled in this cluster, it will create the resource, right? And to finish the demo, let's try now with DEX. So let's try modifying the AuthConfig, adding another trusted source of identity pointing to the DEX SSL server, right? So if we first try without permission, it will also be rejected by the admission webhook, saying not authorized. So the cluster administrator first needs to grant, or whoever has permission to create role bindings in the Authorino namespace needs to bind the user that we are using here in this terminal session to the role that we defined a couple minutes ago. So if we create the role binding, and now the user tries to modify, as you can see, it's persisted, right? And if we detail here, as you can see, now it says DEX here. And that's it. That's what I had for the demo, and that's how you can use Authorino as a validating webhook service.
Thanks, Guy.